Thank you very much, Django attendees, both in present and remotely over there. Hello, Internet. I first spoke at Django, as been mentioned, at Django on Europe in Denmark last year, and I was so charmed by the city and the weather that I felt that I should come back for a second time. Yeah. All right. Just a little bit about myself. First of all, can you folks hear me inside this room here? I think the people on the internet can hear me okay as well. So, as Ben mentioned, my name is Chris Adams. I have a background working in wacky environmental data startups and have been doing so for the last, say, 10 or 15 years. And to give you an idea, let me just make sure I'm checking the timer so I don't get run over. So Loco 2 was basically all about making it possible to book trains as easily as you book planes. And that's actually the service I used to get from Berlin to Copenhagen today. Amy was another company I used to work at. Amy stands for, as you can see, Avoid Mass Extinction Engine. We managed to burn through $10 million of US VC funding trying to figure out how to sell services around carbon calculation. We learned lots of ways not to do it. And the nice thing that's good now is that I'm able to kind of share those learnings with other people now that there's a kind of new kind of interest in climate, I suppose. These days, I spend my time working on three main things. One of these is called Icebreaker 1, which is all about basically making it possible for either finance or insurance or various policymakers to have access to the data necessary to make kind of informed decisions around, say, policy. The other thing I do is I work with Spend Network. With Spend Network, we basically provide analytics around public spending. So the $13 trillion that is spent every year by the public sector, we provide analytics and tools to help people get better value out of that. And in particular, we're doing some new work about working out the embedded emissions, carbon emissions in various kinds of expenditure, so policymakers can understand that stuff too. The other thing I do is I am a director of the Green Web Foundation, which, as you can guess from the name, is about making the web green. So these are the two ways to get in touch with me. I'm Mr. Chris Adams pretty much everywhere online. So during my time with you, I'm going to cover a few things. These are the topics. I'm going to try and arm you with enough information to help you start navigating this kind of somewhat confusing world of kind of climate, carbon emissions, and in the context of being a technologist. Because in many ways, it's actually quite difficult to find some reliable information. And when you do look at a lot of the kinds of, say, a lot of the writing, it can be hard to figure out where you should be focusing your time. The other thing I'm going to do is I'm going to share with you a kind of mental model that I've been using or that I'm working on, and I'm sharing it as a kind of work in progress to get some feedback from you folks as well, so I can kind of improve it or see if it is a bit more kind of intuitive and easier to use, so that you might apply some of this as a professional or a technologist yourself. Then finally, I'm going to try and share with you a kind of, I think, a way to kind of like a narrative of it, as it were, for technologists like ourselves to see where we might fit into this kind of transition that needs to happen away from fossil fuels to something which is a lot more kind of climate compatible. And I share this with you because I see people oscillating between this sense of learned helplessness where people say, I'm just a developer, I'm just doing what I'm told, what can I do? Or people saying, I'm a developer, I'm going to fix this, what coding skills should I learn? As if like this is a coding problem, not a much more complicated problem than that. So I'm going to try and share a framing with you, which I think should be useful, and I've found helpful when I've been thinking about like my role as a technologist in like the climate crisis. So before I go too deep into this though, I want to try to limit the scope of this talk. So as you might have noticed, we're in the middle of a pandemic. Hello, people who are not here today. But as this cartoon, which has been doing the rounds on social media shows, there are all these other crises unfolding too, from biodiversity to a recession and things like that. And a lot of these are really, really terrifying too. But I do not think I can address them in a keynote talk at a Django conference in Denmark. So I'm not going to try to do that, and I'm going to focus on what we can do as professional technologists. So while I think it does matter about the decisions about what you eat, where you fly, and all the lifestyle decisions, I'm not going to be talking too much about that. And I'd request that we don't spend too much time on that because I think it's going to be a distraction from our roles as professionals. So, have we got 2 slides there? Yeah. All right, so let's start with what I hope should be a really, really uncontroversial and blindingly obvious statement. And the thing I really want to kind of draw your attention to in particular is the last part, which is finding a path off of them. Now, it's loads of fun to geek out about things like, say, carbon removal or growing trees or things like that. And I've been guilty of this as well. Now, the thing is, I'm going to share with you an analogy which I found useful, because I think I kind of have this mental model in my internally of us, like society, as a patient in an ER room, like emergency room, and we're bleeding out, right? Now, if you think about all these other things, they're good, right? They feel a little bit like pumping blood into someone, when what we really should be doing is stopping the bleeding in the first place. And I feel that when we don't talk about fossil fuels and the role in society, it's like we're not talking about the fact that we're still bleeding out and we need to be doing something about that thing first. So this is why I'm sharing this blindingly obvious slide with you, because you'd be amazed how much money and attention is being focused on things which are not about getting off fossil fuels. Now, these words here, rapid, far-reaching, unprecedented, these are the word for word from the IPCC report. And the sheer scale of the changes are daunting, yes. And it's worth remembering that the scientists who have been spending years looking into this stuff are using phrases like this because IPCC scientists tend to be very, very conservative in their recommendations. And when they're using these kinds of words, that's the equivalent to them jumping onto the desk, grabbing us by the ears and screaming in our faces to get our acts together and stop accelerating towards that iceberg. So rapid, far-reaching, unprecedented. I think it's really, really useful to remember these words and use them as a kind of test for when you see people talking about the next thing that will kind of save us on a planetary scale. If the things that companies are announcing are not rapid, far-reaching, and unprecedented, then maybe we should be aiming higher. Now, let's think about this. So what would rapid, far-reaching, and unprecedented mean for the internet, for us, right? There's one thing I can think of immediately, and it's in huge letters on the screen. And I think this is because right now, every time we use the internet, and we are professionals, I assume, who our livelihood in our jobs, and we spend a lot of time outside of our work as people using the internet, we end up contributing to climate change, whether we like it or not. And you can make the argument that yes, pretty much every kind of economic activity also contributes to climate change. But this one really feels a lot more solvable than most, especially when you look at the last 10 years of how our use of the internet has changed. Now, I'm sharing some charts now with you because I think it's useful to get some context and to help address some of the kind of scare stories around the internet and the use of technology, I suppose, and the carbon footprint of this. Now, it's generally quite safe to think of kind of the tech industry and data centers and the internet are at around 1 to 2% of global emissions. So that's roughly the same kind of ballpark as all of shipping or most of aviation now, or Canada or Germany. So it's that kind of figure. So it's not small, but it hasn't been growing as fast as other industries. All right, and there's some reasons for that. One reason is that we've basically seen that there's been a lot of investment in actually making things get better in efficiency. But I'd also kind of put to you that if you think about kind of things that are kind of civilization scale, right? 1 to 2% of global emissions, for all the good and all the kind of utility we get out of that, I reckon that's a relatively good deal, even though we need to get down to zero. For comparison, we've seen in the last 10 years, say just the increase in emissions from SUVs, that's more than 2 internets worth of CO2 emissions. And I've got to ask yourself, what would you rather have, 2 internets or more SUVs in the last 10 years, right? This is why when we talk about this stuff, we need to have some kind of context here. And it's worth thinking about the shifts in the industry there and how that's affected how we work. All right, the efficiency, the way that we've managed to kind of rein in this in growth, even though we've seen massive increases in use, is largely because we've seen a shift from running, say, working in traditional data centers to working with hyperscale or cloud services in many ways. So we've seen this consolidation amongst the big providers at the expense of much smaller data centers. And you've seen the same thing at the network level now as well. So Cloudflare, Amazon, and Google, loads of traffic is basically going through a number of small companies, a small number of very, very large companies, rather than this whole kind of more decentralized system of that we've had over the last 10 years. And I'd kind of say that when people start talking about like the internet and data and stuff like that, I don't think the problem is that we're using power. I think the problem is that when we use any of this stuff, it ends up emitting carbon, and that means we end up burning fossil fuels for this. And so that's like the thing I really want you to be aware of. Now I'm just going to share a few kind of other concepts which I think are quite useful to give you some kind of words, and I'm hoping there are some kind of database nerds who've got the MVCC joke here, right? I mean, we're Postgres friends, right? Okay, so I'm going to share two sets of ideas which I think should be useful for you. So the first thing is to think about carbon emissions and how to think about it. If there are basically established ways to talk about and measure and kind of optimize the emissions of any organization or even a country, or even like, I guess, going down people, but really it's much more at the organizational scale that we probably want to do something with it. There's like scopes, and I use the medium of coffee because that seems to be a subject close to many a developer's heart. And you can think of it like this. So scope 1, this is emissions from burning fossil fuels yourself. If you have gas at home and you heat up a kettle, that's your scope 1 emissions. Now scope 2 would be using a kettle. Someone else is burning fossil fuels for you and you are benefiting from the electricity. So that's kind of your scope 2. Now scope 3 is the entire supply chain. That's like you walking into your favorite third wave coffee shop and all the things involved in actually making it possible for you to have coffee. That's your scope 3, so that's your supply chain. Now, we can make this a bit more concrete by looking at some organizations, some companies you might have heard of, see what their scope 1, 2, and 3 figures look like. So this is Stripe. Show of hands for people who are in the room who's heard of or used Stripe. Okay, so good. All right, it's a company that you're aware of, and many of us might look up to as people who are really, really good at doing running digital services. So their scope 1 is pretty small because they basically just heat buildings. Scope 2 is, yeah, they probably need to turn lights on rather than working in the dark sometimes. But scope 3 is probably the big thing for them because they are massive customers of AWS and Google Cloud and people like that. So that's probably where they're going to have the most impact if they're going to make any changes. And also employee commuting, because that's a significant chunk. Probably one of the biggest ones we've seen a change in over the last 6 months or 9 months now. And yeah, flying, because that tends to be quite an impactful one as well. How about Amazon, for example? Amazon actually has quite large scope everything, really, because they're just so huge. I mean, yeah, as you can see, this is 2 years ago, and this is a carbon footprint of Finland, and they've only been growing. So scope 1, Amazon literally have their own airline, so they're going to be burning a lot of fossil fuels themselves. They also run a lot of service. They own about a third of the cloud market, so that's going to be quite large too. And because they have so many deliveries, or so many people with Prime, the lion's share is probably going to be from scope 3 from them, which is why them investing in things like electric vans is actually quite an important thing, because that's probably going to be where you're going to see some impact on this. Now, if you are, Google's another example. Google don't really ship that many physical products, but they ship information, and they use loads and loads and loads and loads of servers. And the graph on the left-hand side here shows basically Google's growth in emissions over the last few years. And you'll see that on the right-hand side, if we only looked at the power they pull out of the grid, because you do not control if you're connecting to the grid where the power comes from, you'd see what their emissions would look like this. But because they've been investing, they are literally the largest corporate investor in renewable power, their emissions end up being somewhat lower, and we'll explain that a little bit later. But this gives you an idea for how you might use these. Now, yes, if you are interested about this, or you work at a company which might have you might ever have these kind of conversations yourself, literally across the other side of their city, there's a company called Tomorrow, and they are building tools like this that you can use and try out. And these are really, really cool people. They're also hiring, I think that it's worth looking at this stuff here, because they figured out that you can actually work out these numbers inside an organization based on activity data in terms of like the kind of spending that you might actually do. We use similar models and similar approaches for Spend Network when we're trying to understand the carbon footprint of, say, 100 million euros of public spending, but it scales down at an organizational level. And there's a number of companies that are now doing this, but these folks are in the same city as you and they're looking for beta testers. So I'd really recommend speaking to them. So this is like how you might apply this yourself if this has you kind of interested and you're trying to figure out where you might want to focus first inside an organization. Now, I think it's taking a while to, yeah, there we are. Now I'm going to share a little bit about understanding energy markets, or just enough for you as developers to understand some of the cost structure which affects the bills that you might be responsible for choosing as a developer yourselves, all right? And this is one level down the stack, but I'm hoping by the end of it you'll understand why I'm sharing some of this with you. So hopefully some of this should be kind of something that you might be able to recognize yourselves. It's really weird having two sets of people to speak to. Hello there, I haven't forgot you, right? It's, if you think about like how you might say buy services for any kind of digital like application or something, you might have things like, say, bare metal service. You're familiar with these. Like this is the stuff that we usually use, or we used to use maybe 10 years ago. A lot of us might have shifted to virtual private service, where we accept a slightly higher cost because it's just easier to handle. And then some of us like use things like Heroku, where you literally have a slider telling you, which lets you handle scaling rather than you having to remember how to do this stuff or run Ansible or something like that. Then finally, at the other end of the scale, you've got things like functions as a service now, where to an extent, the scaling is built into the system where you are not thinking so much about it yourself. But in return, you're paying more per unit for that. And like this is a concept that I think as technologists, we are likely to have internalized over our career. And there's a kind of equivalent in the energy sector. And this is it's useful to be aware of this because it helps us make sense of this shift that's happening and how it might affect us. So this is how things work in the energy sector, all right? Generally, you've got different kinds of ways of generating power, and this is how it used to be. We used to have nukes at the bottom, really expensive. They're like the bare metal servers of the kind of power world, right? They're really expensive to buy, and then if you can use them all the time, you can kind of more or less make them work, but they're really hard to scale up and down, all right? Next one, coal. It's a little bit like the kind of EC2 of power, I suppose, all right? In the sense that you can scale it up and down, but it's a little bit more expensive per unit. And then finally, you've had things like natural gas, or what I see a lot of people referring to as fossil gas, because that's where it's from, where it is a kind of a little bit like the serverless of energy, in the sense that you use it to have, you'll use it, you can charge a high amount for it, and you tend to have it on not all the time. So you don't actually, you'll find cases where there are kind of gas-fired power stations that only are turned on when there is loads of demand on the grid, and they can charge such a high rate for that price that they can still make it work commercially for them. And this is and I think it's useful to be aware about this. And this is how it's kind of run for the last, say, 10 to 20 years. Now, we've seen some interesting things happen in the last, say, 10 years, like solar has come into the market and renewables. Now, renewables are interesting because they, unlike all these other ones here, there is no fuel, there's no coal, and there's no fuel to kind of pay for when you run this. So they can be cheaper than any of these here. So if you run a nuclear plant and you've just built this with the assumption that you'll be able to kind of own the lower part of the market, selling at a really low rate for ages, you're not going to be that happy about about solar coming in, because it totally messes around with the actual pricing and your economic model. And I think it's also means, let's see, where am I here? Yeah, but this happens, but only when things are windy or sunny. So you've now got volatility into like the market, I suppose, where you didn't have this. Now, I think it also means that because you've got more generation in there, it kind of pushes the cost for many of these things slightly lower, and it means that prices can be lower for power than they were before in times of abundance, when there's loads of sun or loads of wind, for example. And because if you run, say, the national grid, you need to kind of balance out the grid all the time, all right? And if you need to do this, if you've got more power coming in than people are using, then you need to end up having, the people who run these grids basically end up speaking to people who run power stations, say, hi, can you kind of turn it down a bit, please? Now, the problem is, it's really difficult to scale some of these things down, and it's very expensive to, say, scale down like a nuclear power plant, for example. It happens over a series of, well, days in many cases, and it can damage the things. So in many ways, it's often cheaper to just pay people to use this spare power, which means that power prices end up being negative, which is like a kind of weird for us because we're used to like paying for things. Now, what we're seeing recently now, in the last, say, 5 to 10 years, we've seen the introduction of batteries into like the power grid. Now, this is kind of weird. It's like you've got this pincer movement from the future with renewables coming in, right? So you've got like renewables making things way, way cheaper here. And when the power is very, very low, you've got this another form of basically dealing with a real high demand for power in the form of batteries, right? And essentially, you've got cases where you might have batteries which are paid to basically take power off the grid, then sell it back when it's really, really expensive, which pushes off or loading these things off the grid. So these are some of the dynamics that are affecting how we might actually, when you think about, say, computing and like, say, data centers, because so much of the costs of running infrastructure is from power, this stuff is going to affect what we do as people higher up the stack, all right? And I think this is probably some of the stuff that's useful to be aware of. And now that you're aware of this, I think it's, when you think about stuff like this, I'm hoping it might kind of make you think a little bit differently about how we run services. So a lot of us, we might build a thing which is maybe a software as a service solution for people who are at work. And like when we are aware of this, we realize that we might be thinking about this in terms of something run all 24/7, when really it's not being used all that time. And there might be other ways of basically designing things for that. Or it might be that if you were building something like, say, if you were to design for this kind of responsiveness, you might be able to reduce the amount of energy needed and reduce the amount of fossil fuels being burned as a result, and also probably save some cash. And this is some of the ideas that, this is why you see a lot of buzz around things like serverless and stuff for this, because I think that you see there are parallels between these two things. And this basically becomes more attractive and it's kind of greener in that sense. So this is some of the stuff that's happening, which is useful to be aware of as a technologist in terms of climate. Now, I want to share like a mental model with you, but the reason I'm trying to share a mental model in the first place is because I think it's a useful idea that we've seen work in other places. So has anyone heard or come across the phrase poor here? Okay, so this is the phrase that developers use who work in accessibility circles, all right? Now, this phrase, poor, stands for perceivable, operable, usable, and robust. If you are a front-end developer, you will learn this as a way to remember to design in a way which is much more inclusive and accessible. So perceivable is this idea that if you're going to build something, you need to make it possible that people can perceive the content. And if they cannot see things, you need to make it perceptible to the other senses. So this is like this is what perceivable refers to here. Operable might be this idea that, okay, if you're designing say a site or an application, you can't just assume that people are using a mouse and keyboard. And in many cases, when you're on touch devices, yeah, you don't have either of these things. So there's all these affordances you need to take into account. And when people do not have strong motor skills, you would also need to account for that kind of stuff as well. So that's operable. Now, usable is kind of obvious, but in many ways, if you can't understand what an interface is telling you to do, then you're not going to be able to use it. And if you are, say, neurodiverse, for example, maybe having lots of things move on screen means that you also can't use it. So that's the idea of usability, usable in this. And then robust is, okay, you know that thing where if you use a website, like a single page web app on a phone, and you've got a crappy connection, you're just waiting for a megabyte of JavaScript to download before you can do anything. This is like not a robust application, especially if you're just trying to access a little bit of text, right? A robust version of this would be, we send the text first, then we progressively enhance to something which does have this rich experience. So things like poor help developers internalize this, and people will refer to this. And these are actually principles in the guidelines that people use to see if a website passes or fails a test. And basically, websites get sued over this stuff, and we'll refer to these particular kind of principles. And this is the actual kind of quote I probably should have led with actually. If you can make it easy to remember, then it's going to be more likely that people will remember to actually design in this kind of way. And this is kind of the thing I want to share with some of you, I suppose, or I want to kind of get some feedback from or test with you. What if we had poor, but for designing stuff, given the fact that we're in a climate emergency and pretty much everything we do runs on fossil fuels, and if possible, we'd like to not couple what we do to all the kind of unintended impacts of basically running an entire grid on fossil fuels. So this is the one I've been working on. It's called Green, Open, Lean, and Distributed. And I figured, like, most people like gold, or at least the idea of gold is somewhat aspirational. You know, would you like gold? Yes, please. Yeah, that's the kind of idea I'm going for. And I'll break this down in a bit more detail now. So green, as in green energy or kind of low carbon power. All right. Now, I spoke before about on the grid, there's this idea that you should be running on green power. And the reality in many cases, if you were not running a gigantic hydro generator in your own kind of office, which there's actually one place that does do that, you don't have that much control over the grid. So when people say we're running on green power, there's lots of different ways that you say that you might actually be doing that. And I might say Denmark, for example. Denmark is pretty good. When I was on the train here, I saw all these cool-looking wind turbines, and that made me feel very, very happy. All right, but there are parts where I don't have control over. And if you wanted to say you're running on green power, the thing you need to do is you need to account for this. All right, and the one approach, which I think is probably the best approach I've seen so far, is the approach that Google and Microsoft are doing, where they basically match the power they draw from the grid, the kind of fossil power, and they feed into the grid the same amount, so they could say that they get to say that all the power is green. And it sounds kind of a bit weird and possibly somewhat unsatisfying in this sense, rather than just literally hooking up a solar power to a server. But this is kind of how a lot of this is going to work, because it turns out that having kind of uninterrupted power and having access to utilities is kind of useful, especially when you don't have power running all the time. So this is the one that I think is actually quite attractive. And this, again, when I refer to like in Denmark is actually one of the kind of hotspots for this stuff. That same startup Tomorrow, they're actually the people behind doing some work with Google, and they provide these kind of stats for you to work these figures out yourself. The other approach that lots of companies do is that they just offset the carbon emissions. And this is what some people do, because to understand markets, it takes quite a while to get your head around, all right? And you can do this. And when I work at the Green Web Foundation, we've accepted people doing this because it's better than nothing. But sometimes the question you might ask yourself is this solving the problem that everything we do with the internet is actually having this kind of unintended harmful effect? Like, I'm not sure it is, but it's better than nothing. And all you're doing is basically accounting for the carbon emissions from these two things and offsetting it that way, right? Now, if you wanted to really kind of dive into stuff like power, if you want to say, oh, well, you're doing it wrong, this stuff is really, really, really complicated. I've spent like 2 years trying to get my head around it, and it's still, I still am struggling to kind of understand all of this stuff. And I think it's worth bearing this in mind when you see people talking about, oh, we're running on green power, and people being quite dismissive. It's actually quite hard to get your head around this, but it's something we should probably be aspiring to. So that's green. Now, open. Open is kind of the stuff that if we're nerds, we generally like the idea of open in terms of open source, open data, transparency, stuff like that. And I spoke before about, say, understanding how much fossil power is on the grid if you wanted to kind of zero out or be running on green power, right? Now, I feel like, I'm so sorry, this sounds like an advert for this company called Tomorrow. They basically, it's not, but I think they're lovely guys, but they are mostly guys. That's the only downside. It'd be really cool if there were more women in the company, all right? But they basically make this available. This is a map called Electricity Map, and they track in real time what the carbon footprint is of power anywhere in the world they have access to. They basically take open data and put a nice interface onto it that you might want to consume or use yourself. And this is how they are working with companies like Google to come up with a more transparent way of accounting for the carbon emissions. But the key thing I want you to kind of take away from is the idea that depending on where you are in the world, your servers will have a different carbon footprint, even the same code. So if I took the same code in Denmark, it's kind of not bad. If it did it in Poland, because there's so much coal on the grid, it's going to be much, much worse. And then if I went to Estonia, which is really, really bad, it's actually Estonia's not a lot better now. But generally, you'll find this like an artifact of the carbon footprint of your application is where you choose to run it. Now, France is full of nukes, so it's really, really low carbon. But if you're not a big fan of nukes, that might also be something on your agenda. So this is one thing this is one lever you might have available to you. And open in terms of like it's quite useful to have that. The other thing is that when we have open platforms, which I kind of consider Django to be, it means that we can get loads of optimizations from elsewhere in the stack. All right. So even if we were to think about, okay, let's go for the kind of cleanest, fastest, most efficient possible code, because we're running on, say, something like Postgres, we do not need to actually resort to introducing loads of other bits of kit that we might have had to use elsewhere, simply because the stack we're using has a kind of really clear interface point to add new capabilities. And two examples I think are quite cool are if you're working with, say, any kind of time series style data, you can basically like get reductions in the actual, say, resource needed just by having a different extension, which takes advantage of some of the ideas that we might see in, say, Cassandra DB or other databases, which is actually, I think, kind of cool. And basically means that we get to still work in Django and we get the benefits of all the kind of no SQL kind of stuff. Likewise, if you work with data warehousing, because Postgres is an open source database designed to be accessible to lots and lots of people, there are some things there are some decisions where they favored accessibility over efficiency. But again, we can use an extension to take advantage of things like that. So things like, say, Pandas and NumPy, they are designed in such a way that they can use some of the advances in CPU processors like SIMD and other advances to make things work way, way, way faster. So you can basically get a lot more performance from the same kind of kit. And again, there are extensions that let you do that kind of stuff. So there are actually things available to us when you have an open stack in clear ways that you can actually get integration points from. And if you tend to use MySQL, you'll see the same thing. Like MariaDB has similar tools now because they decouple the storage from just having something like SQL at a higher level. So this is some ideas of like open standards and so on. Now, is this working? Trying to get to the next slide. Yeah, okay. Yeah. Oh, whoops. That's two seconds, folks. Sorry. The L is for lean. If you're going to emit carbon, at least make it count. Now, I found that it feels a bit pointed to a flame graph when we're talking about like literally forest fires and stuff like that. But I actually find that flame graphs have been one thing that I found really useful. There's a book from I think Adam Johnson. He created a book called basically how to speed up your Django tests, and he talks about how to use things like, say, flame graphs here. Now, the thing that's kind of cool is when you run a command, this is a tool called PySpy, which you can use for any kind of test suite or anything like that. And it gives you an idea of like what the call stack is when you run a command, and then what's happening here, and then basically which tests are making things slow. And this gives you an idea of where you might, it gives you a kind of visual way to kind of think about where to optimize first. I just have to, folks, I think I'm running out of power, so I might need to have some power plugged in a second. I've got this one here. Yeah, and if you can plug it in there, then that will help me save the day. Thank you very much. That's why things start to run slow just now. Good Lord. Okay, so that's one thing. The other thing, if you care about, say, because we're working in the Python ecosystem, there's loads of other cool things we can do. Now, there's a group, so there's a lot of work in the kind of green AI movement where people are trying to figure out how to understand the actual carbon emissions from code itself. And you literally can just pip install energy usage, put a wrapper around what you do, and then you can get some figures out of this now. And like they've literally put a kind of API on all the kind of complicated stuff internally for this. So if you look at this, you'll see that they'll figure out like where something is running in the world by hitting like a GeoIP thing. They'll take into account all these things about carbon intensity, like I showed you, and you can get some figures for this. And it was initially for things like, say, AI, largely because you have loads and loads of machines crunching numbers for a long time. But it's stuff that we could use because everything is open as well. And I think it's kind of cool because it's something you can like literally play with today if you were interested in it. Now, so that's like server side. But if we're working with Django, we're talking about the web, and we send stuff over the wire. And it turns out that sending stuff over the wire uses servers which uses fossil fuels because it uses power. So there's chances you can optimize there as well. Now, there's a tool called Lighthouse. Has anyone here used Lighthouse or come across it before? Okay, it's about half the room. So Lighthouse is essentially a way to, it kind of grades you on how green or so how fast and how good your website might be. So you point at a web page, it will tell you what the performance is like, how accessible it is, how good it is for SEO, and so on. Now, last year, I started looking at this and I tried to figure out, okay, can you extend this? Because this is open source. And yeah, it turns out that there was actually an interface where you could extend this. So we started building some things so that if you run Lighthouse, you can now get an idea of the carbon emissions from this. Now, the thing is, I'm a big fan of like lots of things that Google does, but I'm not sure that the priorities of a $1 trillion advertising company are always the same as the priorities that I might have, all right? So there are other alternatives as well. And one example is site speed, which is another kind of web performance analytics kind of tool for this. Now, the thing that's cool about them is they have different priorities on here. So an advertising company might not be so bothered about, say, privacy. And you might, they might not be taking into account things like, say, surveillance, like that thing where you when you visit a page, then you have to wait for a bit while all the auctions run before you actually see any content, all right? Now, site speed's kind of cool. And again, because it's open, you can extend it. So we did some work with them when I worked with the Green Web Foundation, and we built like a sustainable web plugin that lets you figure this stuff out. So we basically use some of the kind of science and nerdy stuff that I've been doing, and there's an illustrator who did kind of cool Greta cat, which I think is just made me really, really happy when I saw it. I didn't know it was there. But these are like some tools you can use for this stuff to actually see how you might have an impact at the kind of network level as well. And if you think this is kind of cool, there's this whole set of new companies who are doing things in this. So there's a company called Cabin now, and they basically do privacy-aware carbon calculating analytics using these ideas here. And they give you an idea of what you might have, and this is actually a real thing, and it was kind of embarrassing. I realized that one of the pages, I totally optimized it wrong. So if I clicked on this, I could jump into it, it could tell me where the big kind of culprits and things I need to fix are. So there are tools which you can use and incorporate into your tool chain to actually understand this stuff in production as well now. So that's lean. Now the final one is distributed. And I hope that I'm talking about distributed in terms of space, which I've mentioned before, but also time. And I think time is the kind of interesting one, more so than the other one. And that's one you're probably going to have some access to. Because if you say, boss, can we please run our servers in Switzerland on Wednesday, then they might not be super keen to do that, because migrations tend to be kind of big, scary things. Now, there is some really interesting work going on with Microsoft right now. There's a guy called Asim Hussain who's been building a website called principles.green. And he talks about this idea of shifting demand or your use of compute to kind of match what's on the grid. And to an extent, when we use anything like, say, a cron job or a queue like Celery, we're kind of already moving work through time. We're just using it for, say, performance reasons rather than green reasons. And because we spoke a bit more about, because we covered before about, say, because before we were talking about things like, say, the cost of energy will change depending on what's on the grid and things like that. There's actually a chance for us to go from rather being just consumers, we can be active participants in the grid to help balance it, and in some ways be paid for this. And like, here's the kind of like concept I want to share with you. There's this thing called the duck curve, partly because it's kind of duck shaped, right? And this is like an actual academic thing that people, there's a whole load of people talking about this in the energy industry around this. And generally, when you have lots and lots of power on the grid, you'll see this case where you basically have more power than could be used, right? And like we said before, because we know that like nukes are really hard to scale down and fossil fuels are like coal is hard to scale down, it's often cheaper to just pay people to use power than basically pick up the phone for the guy at the nuke station and say, hey, can you like poison your own nuclear reactor for a couple of weeks? Because they're just going to say not like they will not want to do that. And you end up with a case, I think like this kind of stuff will end up being exposed to us as developers more over the coming years, simply because it's going to be a way to essentially pass this on to end users so they can do something with this. And in Django land, we're already seeing this at the consumer level. So Octopus Energy are a kind of well-known Django shop in the UK. They have a really, really good style guide if you're a Django developer, which I use all the time. But they've been doing this kind of stuff. They call it plunge pricing. And as a end user, a consumer, you'll be paid to use power at certain times. So they can pay you to basically wash your clothes at 2 a.m. rather than say when there's a peak at 6 o'clock when everyone gets home. And this essentially is what you're seeing examples of kind of Google do stuff like this now. All right, Google have got a lot of press recently by shifting their their workloads to when energy is cheap and green. And I think that it's not just Google who's going to do this kind of stuff, because 10 minutes left. Okay. Oh, great. I'm ahead of time. Great. So I think this is actually something that we're going to see more of, simply because there is actually just in many places, there is actually quite an increase in data centers going onto the grid. Now, to give you some perspective, Denmark, their own energy projections, their energy agency in Denmark have basically, they put, say, 15% of all power in Denmark to be used by data centers by 2030, all right? So 1 in 6 watts is going to be doing this kind of stuff, all right? And it seems it's useful bearing in mind that data centers are one of the most energy intensive per square foot kind of buildings that you could possibly have, even more than, say, aluminium smelters, which are traditionally the things that are really, really energy intensive. And I feel like there's this chance which this kind of stuff totally changes the economics of how we might work as developers, when the thing that you're using might actually be, rather than a cost, it might actually be a kind of source of money coming in. So like if you design it, I think there's a chance to design accordingly for this. And I think that this is the kind of stuff that if you are not aware of, and if you don't understand the context in which it's going on, you'll understand why are people so excited about this stuff. Because I think it changes how we might work and how we basically, the economics of what we do. So that's like gold, green, open, lean, distributed. It's like a work in progress. So I'm not sure, and I really welcome kind of questions and feedback, or whether you could see how you might apply it in your own kind of context, I suppose. The final thing I'm going to share with you is this idea, which I found quite helpful, stacktivism. If you're a developer and you care about this stuff, you'll notice that I've been referring to Google and Microsoft again and again and again and again and again. And like, I think it's because this is the problem. This is the choice we have to make as technologists right now. If you care about, basically, you get to choose 2 of these, but never 3. All right, fossil fuels, kind of important to be doing if you're a responsible professional. But also, if you're a responsible professional technologist, you'll often, in many cases, choose to use a hosted service rather than have all your development time doing a thing which is not core to what you're for or what you're working on. The final thing is also, in terms of like having kind of healthy ecosystems, consolidating all of our spending around 3 companies who are also helping drill for oil, probably not that good an idea in the long run. All right, but right now we can only pick 2 as professionals, and that kind of sucks in my opinion. And I think that we need to think about this, about the stacks that we build and what we choose to build, what we choose to work on, because I think there's stuff that we can actually do as technologists to address this. So these are the primitives we might use when we are developers or building any kind of digital service. Compute, storage, network, this stuff we know about, right? Now, these might manifest themselves as, I know, paying for virtual servers, some kind of object storage like Amazon S3 or something compatible, or some kind of software-defined networking like a load balancer or a private network or something like that. And like already, just trying to find green versions of this stuff it's not that easy. You do find some options now, but it's still quite hard to actually just find green, like 0 carbon object storage in, say, Denmark, for example. You're going to struggle a bit. Now, if you think about the things that a lot of us use now, right, we might be, say, paying someone else to manage a database, because after a few years we realize running databases and managing them is actually quite hard. And if you've had enough scare stories that we don't want that to be our problem to solve. Or it might be something like, say, managing Redis when it goes above a certain size is a pain as well. Or like managing search, all these things. You can pay to get hosted versions of this stuff right now. But the number of companies you can get this from is actually quite low. Likewise, with things like, say, I don't know, Kubernetes, for example. There's 2 or 3 very, very large players. But if you do not want to, if you want to go for all 3 from the choices I made before, not so many options. Likewise, with serverless, we don't have so much there. Now, if you want to kind of build, say, Django applications that scale down to 0 or only are served when your request is coming in, there are ways you can do that. Cloud Run is an example for that. and like Lambda from AWS offers you some stuff like that. And there are frameworks like Zapper that make that possible. But the underlying code is open source. But we're not seeing people use these kind of things. And I feel there's a market for this. Likewise, like all of these projects are open source projects that are things that if you wanted to build a stack, you need to make compromises on right now as a professional. And I feel that kind of sucks. And it's something we should probably address and think about. And if you're going to kind of start a business or work in some kind of service, maybe it's the thing you'd take into account. So this is kind of how I kind of frame it or want to talk about it with other people. Like, I think we need something like fossil-free stacks, right? We need a way to be explicit about what we care about and embed some of the values that we might have into what we do. And I think that fossil fuel stacks kind of needs to go, and like that's because, yeah, we really are out of time. We need to be doing something faster than we are right now. And this is kind of the stuff I share with you. I think if you want to if you're thinking and worried about kind of climate and you're working as a technologist, there's a few spaces that you could actually kind of incorporate this. And I think one of these is, okay, there's a narrative about building a fossil-free future and getting away from what we have right now. And I think finding work in that is becoming easier. And like there's literally 2 or 3 companies I've mentioned just now who are hiring for this kind of stuff. And there's also opportunities that someone is going to make a lot of money out of. And it would be nice if it wasn't just Google and Microsoft, right? And I think that if you want to make the web green, then you can make Django gold. And I think that's kind of largely it. I think I'm a little bit ahead of time. So I'll answer most questions in Doolittle, but if there is a bit of time, I don't mind answering 1 or 2 now. So yeah, that's me. Cheers, everyone.
Thanks so much, Chris. You mentioned questions from Sweden on the internet. And we forgot to mention questions from the audience. So if you do have a question, you're welcome to ask it on Zulip, because we don't have a portable mic ready. And we cannot stream your voices to the internet. So you can also ask a question and I will repeat it from up here. That's the way to go. Yeah. Thanks so much, Chris.
Cool.
Sorry, we should also keep a safe distance up here. So,
what do we do now? Christ, we haven't thought about this, have we?
Joel is our question host, and Joel is ready on Zulip. So if you have any questions, please ask them, and Joel will forward them, and I will see them up here on my screen, and then I will ask them.
Okay.
And we have about 5 minutes until we have a scheduled break.
Oh, great.
And our breaks are so that we can have a break here at the venue, but certainly also so you streaming at home can have breaks. And we will show on the screen how long the break is and when we're going to resume. I'm still giving Joel a little bit of time in case there are questions, but I do have a question. By clicking a little bit around on Wikipedia, I've seen something called the Jevons
paradox. Yes.
Or the effect. Yeah, it seems that if something becomes more efficient, then we should, in theory, need less of it because it's now more efficient. For instance, with coal, it was so that the coal combustion mechanisms became much more efficient, and then you'd think we would just use less of it. But somehow we started using a lot more of it.
This is actually correct, yeah. So is the question, if I understand it, is how does this play into the world? And like, does making things efficient actually make things greener, all right? And there's actually, it's difficult to see where it's, first of all, this is actually a concept which has been around for like 200 years. Like this was first observed by William Stanley Jevons back in like Victorian times, when he realized that by making steam-powered kind of steam engines powered by coal, when you increase the efficiency there, people just use more steam engines because they're suddenly cheaper, right? And I think this actually speaks to a kind of larger discussion about decoupling. So right now, there's a whole focus around absolute decoupling, which is this idea that we can just totally decouple economic growth from, I guess, the physical impact of what we do. And I think that that's a little bit sci-fi, all right? And I don't think it's actually that convincing. And there's relative decoupling, which is yes, you can make you can decouple these to a degree, but you still need to make other decisions. And I think that the best answer would be that for something like Jebit, it's something we should be pursuing anyway, but it's not a get out of jail free card. And in many cases, it's presented like a get out of jail free card, so that we don't need to make any changes to how we live or how we work. And I think there is actually a couple of good papers that I can point you to that do basically address this, and they say the same thing, that yeah, it does have it can create a net increase in the amount of energy, which is basically why I say the thing we need to do is not have fossil fuels in it at all. Like, don't talk about efficiency, talk about carbon, and then I think it's a more satisfying and useful conversation to have.
And if Jebit was alive today, he'd probably say, I told you so.
There's if you want to sound really, really cool and really, really like flashy, there's some people that you can also refer to this as the Kazum-Brooks postulate, because two guys in the 70s and the 80s basically came up with the same thing, and they got a load of press in economic circles. And there's like numbers for it, and there's like a coefficient, and there's ways you can have like a kind of numerical discussion around this. However, that's not my job. I'm out. That's beyond what I can keep up with. But it does sound cool, though, right? Kazum-Brooks postulate. Who's going to challenge you there?
We do have some questions from the internet. The first question is from Joel. Is this where I should paste the questions? Yes, Joel. And the second question is from Rasmus, who's asking on YouTube, which cloud service provider is the greenest today?
Okay, so you know what I just showed you, that kind of stack thing of all these different options. Depending on what you want from a cloud, it's going to matter. It's going to be different. The one that I think is probably the greenest in terms of the most obviously zero carbon is one called the Data Center Lite. Like I work at the Green Web Foundation, and we check. We run a directory of which websites are green and which services are green. And when we got in touch with them, we expected they'd share like some numbers or some certificates. They just like sent a photo of a giant bright red hydro-powered generator, which they use because they literally have a data center in a disused factory, which used to be right next to a water wheel. That's the greenest one, is the one I would probably use if you really, really cared. However, has to be in Switzerland, and they don't provide all the services that you might have, but they do provide a lot of services. That's the one I think is probably the most, if that's one that's worth looking at, if that's your key driver. But that isn't always the key driver everyone does have.
There's a similar question from Joel, and perhaps it's more about leadership. Which companies are really taking lead in the transformation?
So I think it's really complicated, because all the people who are doing really good stuff are also doing really, really bad stuff, right? And I guess, well, that's life, I suppose. But I am really, really inspired by some of the things that Microsoft is doing right now. They are literally running a conference called GreenConf at the end of this. I think it's at the end of this month, where they have a load of people inside the company really pushing for this. They have a head of green cloud advocacy who's coming up with principles like this. And there is a load of really interesting work from there, and a lot of the things they're doing systemically make a lot of sense. But they are also the biggest. They are the market leader in the oil and gas sector. So you've got this problem, and you can make the argument that utterly undermines all the other work they're doing. Likewise with Google, the work they're doing with carbon free, where they've basically tried to balance out power, like you saw, but at a kind of hour by hour basis, which is really hard. I think they're also absolutely leading in that sense. And at the same time, they also have contracts with oil and gas. They are doing less, and in total, I think 2019 they made like $65 million from oil and gas, which is like, let's be honest, that's maybe what, I don't know, 30 Google employees. So for the sake of 30 Google employees, they are running their own name through the dirt, right? But they are now actually, I mean, I'm joking a bit about that, but those are the two companies who are, from a policy point of view, doing some really interesting work. But the nice thing is they're showing what they do. So there is space for smaller companies to do what they do as well. And I think that you could quite easily apply, you could totally take the ideas that they have published, apply them, work with someone like Electricity Map or anyone providing this kind of carbon intensity, and replicate the same thing. And if you are a company looking to do that, with my Green Web Foundation hat on, I would really love to speak to you, because that's exactly what I would like to do as well.
We have two more questions, and then I think we have to finish there. Hans asks, would it make sense to implement PySpy or energy usage into production?
I actually feel that there are better ways of tracking this stuff in production. And again, I'm going outside of my area of expertise now, all right? There are lots and lots of tools that you can use for like distributed tracing and stuff to kind of get an idea of this. And tools like Scout, I think, or various things like that, which you use to kind of track production performance in production anyway. I mean, the math for a lot of this stuff isn't really that complicated. If you know how much power you're using, what grid you're on, you can roughly work out the kind of carbon emissions there if you're running the stuff yourself. However, if you are using some kind of tool from like some serverless tool from Google and Microsoft, they tend to be more cagey about these numbers because a lot of companies see these as kind of commercially sensitive, so they won't share this stuff. If you go to Amazon, you need to be spending at least 15K with them before they will just give you a single number with no real breakdown. Which is partly why we started working on a tool called Green Cost Explorer, which uses Amazon's Cost Explorer to give you these numbers. But like this is, yeah, I think does that help answer some of the question, I suppose?
I think so.
Yeah.
The next question is perhaps also an invitation to join the Zulip chat. Lars Peter asks if you can suggest a list of links for further reading about the subject.
Yeah, the deck that I worked from, every single, basically I was reading a lot of this stuff. So there's like a couple of thousand words in there. There's also a Slack channel, which I help organize called ClimateAction.tech, where there's loads of stuff written in there. I'm happy to kind of flesh this stuff out. And the reason I was really plugging the Zulip thing was because when I spoke to Ben beforehand, we said, hey, what we should do is after this call, we should do a Q&A and edit a Q&A of this stuff. So we have all these links for anyone who was interested by this. And so they got somewhere clear to follow up. And I think, have I used all my time now or is that everything?
Yeah. Let's give Chris a big hand again.